Hello, everybody. I hope you're all doing well and you're eager for some more of the 2011 open paper. We're going to be starting part C of the contest. The last 4 questions, these should be the hardest ones. We'll be looking at C1 right now, worth 10 marks. So we want to do a good job. We want to show all our work, our justification, explain our reasoning, those sorts of things. ABC is a triangle with coordinates 2, 6, 0, 0, and 14, 0. So we see we lie on the x-axis here. Okay. We've got 3 parts here. So sometimes you'll get written questions with multiple parts. If it's later on a contest, I usually recommend reading them all together. You don't have to, but sometimes it can give you a bit of direction. But this is C1, so we can read them all if we want, but I think I'll just read one at a time until I get a reason not to. So A, let P be the midpoint of AB. We can figure that out by averaging the x-coordinates and y-coordinates. There's P. Determine the equation of the line perpendicular to AB passing through P. Alright, yeah, so this shouldn't be that hard. We can figure out the coordinates of P, so that would give me a point on this line. And I can figure out the slope because the slope should be the negative reciprocal of the slope for AB. So the slope for AB is rise over run, which should be 3. Just double check the coordinates there. Yeah, 2, 6. So let's say slope perpendicular to AB is -1 over the slope of AB. Perpendicular slopes are negative reciprocals. So we know the slope of our new line will be negative 1/3. P is midpoint. And so it has coordinates. While the coordinates of A and B added up together and averaged, and oops. So the x-coordinates averaged and the y-coordinates averaged. So this will be 1, 3. P is on our new line. So we get y equals mx plus b, but this is -3x plus b. And we know that y, 3, is equal to -1/3 x, 1, plus b. So 3 plus 1/3 is equal to b. B is going to be 10/3. So what's our line? Y equals -1/3 x plus 10/3. Okay, so that's A part. Very, very nice and quick, as long as you're familiar with concepts like midpoints and negative reciprocals giving you perpendicular lines. So B part, let Q be the point on the line BC, right here, for which PQ is perpendicular to A. Oh, sorry. I thought it was midpoint. Silly me. My mistake. For which PQ is perpendicular to AB. So we actually are just extending this line. Okay. Determine the length AQ. So I can figure out the coordinates for P. Certainly. And then I could... Sorry, did I say P? I could determine the coordinates for Q, because it's going to intersect the line BC, which as I already said verbally was the x-axis, with the line through P. So that should be fine. And then I know how to figure out the distance between 2 points in the plane. So Q is on BC, which is x-axis. So, and on line, well, so it's on the x-axis. Therefore, the y-coordinate is 0. So let's say Q is at Q0. Well, then 0 is equal to -1/3 Q plus 10/3. So -10/3 is -1/3 Q. Q is going to be 10. So our point Q is at 10, 0. Okay, what's the distance between, or the length AQ. That's what we want, length AQ. So AQ, square root of the square of the difference in the x coordinates plus the difference in the y coordinates. And I suppose technically I should have the order here, but the order doesn't really matter. So that'll be square root of 8 squared plus 6 squared, or the square root of 64 plus 36, and that's 100, so square root of 100 is a length of 10. So length AQ is 10. There we go. Okay. Alright, so C part. Do we have a point R or something? There is a unique circle passing through the points A, B, and C. This is called the circumcircle. Determine the radius of this circle. Interesting. So determine the radius of this circle. Well, how you approach this question might depend on how much geometry you know. Okay? So one way to do the question, if you don't know much geometry and you just know, okay, A, B, and C are on this circle, how do I find a radius? Well, if I found the center and connected it up, we'd have the same r length. And so you could imagine a hypothetical point x, y, and compute its distance in terms of x and y to B and to A and to C, and make sure that all those are equal. Now that's going to be, I would say, very difficult, and it's going to involve at least one quadratic that might be quite messy to work with. But one way to do this with a little knowledge of circles, a little knowledge of circle geometry, is to know that if you're looking at a circle and you've got the center of that circle and you have a chord, so just a line connecting 2 points and the line is wholly inside the circle, that if I drop a perpendicular line from the center of the circle to that line, it'll pass through the midpoint of that line. And so if we imagine, say, a circumcircle through a triangle, this could be very useful, especially because in our picture we've already got this midpoint P, and we've got a line going through it perpendicular. So O must be on, so center of the circumcircle, I might say, we'll call it O, is on line through P perpendicular to AB. Now that's true, it's also on line through the midpoint, maybe call it R, because we don't have an R yet, of BC perpendicular to BC. Okay? You don't just have to do it with one, if it works for all the sides. And so I'll just get two lines, I'll intersect with this O, and then I'll use the distance formula like we did in part B to maybe find the distance between A and Q, A and this point O, or maybe A and B, because B is the origin. That'd be really easy to work with. So R is at, what do we have, 14 plus 0 over 2, and then 0 plus 0 over 2, so 7, 0. A line perpendicular to the x-axis looks like x equals A. Therefore this line is x equals 7, because R needs to be on that point and it needs to be perpendicular to BC. And just remember that BC is part of the x-axis. Okay, so we're looking at x equals 7, so O is the intersection of x equals 7 and y equals negative 1/3 x plus 10 over 3. Well, this is really easy because we've got x equals 7. So this is going to be 10 minus 7 over 3, or 3 over 3, which is 1. So O is at 7, 1. r, which is the radius, is the distance from O to any of the points. I'll just do O to B. So 7 minus 0 squared plus 1 minus 0 squared. And so that'll be 49 plus 1, square root of 50. I suppose we could take that as 5 root 2 if we want it in completely simplest looking terms. Root 50 would probably be a fine answer. But I think that's all we need is the radius of the circle. And there we go. So that's our first Part C question done. We've got 3 more to go, and then we're done the contest. So if you'd like to, join me for C2, all the way down here, in the next video. Until then, take care.